Section 4.1, Counting Principles. So we're going to learn about something called the fundamental counting principle. When we look at the word fundamental, it has a hidden word, and that word is and. Anytime there is an and, we use the fundamental counting principle. And the fundamental counting principle says that if one task can be performed A different ways, or 5 times, another task can be B times, or 6 times, then both tasks doing A and B would be 5 times 6, or 30 ways to do it. I'll show you an example. Imperial basketball team. We have a jersey, and it's reversible, and it is reversible to be black and white. And then each one of the boys, believe it or not, has white shorts, black shorts, and burgundy shorts. And I don't even know how to spell the word burgundy. Burgundy. Anyways, burgundy. Okay? So my question is, how many ways can we create our uniform? In essence, is I'm saying, how many ways can you wear your shirt and your shorts? So I am really doing the fundamental counting principle. So what that would mean is there's 2 ways to do the shirt, there's 3 ways to do the shorts, so there's 6 ways to do the uniform. Another way to do it is a tree diagram. So you can have a black jersey with a black shorts, with white shorts, or with burgundy shorts. Notice I didn't spell burgundy. Okay, or you could have a white jersey with black shorts, with white shorts, or with burgundy shorts. So notice that this is still 6 cases, exactly what we found with the fundamental. This is called a tree, fundamental counting principle. This is called a tree diagram, just in case a question asks you for that. Okay, so we can extend this to more than 2 cases. A luggage lock opens with the correct 3-digit code. Each wheel rotates in the digits 0 to 9. Something to know is there's 10 digits between 0 and 9. There's 1 through 9, there's 9 of them, and 0 is 10. How many different 3-digit codes? Okay, so in your first dial, you have 10 numbers to choose from. In your second dial, you have 10 numbers, and your third one, you have 10. So basically, you're saying how many ways can you do this, and this, and this. The word and means fundamental, so we're going to times them together. 10 times 10 times 10 is 1,000. Okay? Second part of the question says, suppose each digit can only be used once. So that means the number 999, 333, 777, even 717 is not allowed. So what we're going to do in that first dial, you have all 10 digits to choose from. In the second dial, you've already used 1, so you only have 9. And you've used up 2, so you only have 8. So it's going to be 10 times 9 times 8 different ways. Okay? And I finally want to show you this last one, solving counting problems when the fundamental counting principle does not apply. So you're going to know it's not applied because you'll see another keyword, and that keyword is the word or. You see the word or, it doesn't apply. So this page is in your textbook. It's very valuable if you're not that familiar with a standard deck of cards. It lays them out really nice, so it's really easy to count the number of cards. 52 cards in a deck, 4 suits of 13, 26 red, 26 black. But a good way if you're not that familiar, or just a neat visual. So this says count the number of possibilities of drawing a single card and getting either a black or an ace. So because we don't use the word, oh, I actually wanted to be on this page, sorry. Because we don't use the word and, because we use or, we're not going to use the fundamental. I'll show you what Christian did. So he drew a Venn diagram. He said, draw a black face card. He drew a diagram. He said, you know what, there's 6 ways that we can draw a black face card. King of clubs, king of spades, queens, and jacks. Or draw an ace. Those are the 4 ways to draw an ace. Notice that they're disjoint. There's nothing in common. So we said the number to do A or B, we just add them together. 10, 6, and 4. Okay, here's where it's more confusing. Either a red card or a 10. So look, here's all the red cards, and here's all the 10s. I really like this diagram. But notice there's some overlap. These 10s are both red and 10. So let's look how Christian dealt with that. So he said, well, there's 26 red cards, 13 and 13, and there is 4 10s. So I go, my number is my number in C, D, minus Well, it's overlapped because it's been counted twice. These 10s have been counted in this 26 and also in that 4. So we did 26 plus 4 minus 2 and got 28. Okay. Yeah, just about disjoint and non-disjoint is on this key ideas in your textbook as well. Okay, so we are teaching you again in grade 12 how to count. Counting is going to come into play because we're going to be doing probability. So it's really good to do these questions because otherwise once we get to probability, you won't be able to count. And life's not that great if you can't count.